Taiwan is undoubtedly a technology island. The Taiwanese semiconductor giant, the Taiwan Semiconductor Manufacturing Company, supplies 90% of the world's advanced chips, which is a concentration that is much more significant than the oil supplied by Saudi Arabia or OPEC to the world. Many of its customers are global technology giants dominating the news, economy, and politics, such as Nvidia, Tesla, and Apple. But how much do you, the non-semiconductor folks, perhaps really know about this industry, and how are semiconductor chips increasingly important to today's world?
Nice.
Every day from the moment we wake up, we rely on semiconductor chips. From the alarm on the phone that wakes you up to the hairdryer you use after a shower, the escalator you take to enter a train station, the train itself, the ID scanner to the office building, the lift, and the office door you enter, literally everything revolves around semiconductor chips. Semiconductor chips are indispensable as we need them to process, store, and control the data required in electronic devices in order for them to function. Without them, the devices would be very sluggish, limited in capability, and difficult to maintain. Let's take a step back and start here. What is a semiconductor? Firstly, a conductor like gold, iron, or copper allows electrical current to flow, whereas an insulator like rubber, wood, plastic, or diamond resists electrical current. So a semiconductor sits between the two. It means that sometimes the electrical current flows and sometimes it does not. By adding impurities to it, or more easily understood, doping it, the electrical current can be activated. So by artificially adding impurities to certain areas, we can determine where the flow of the current would happen and where it would not. So why do we need to dope semiconductor materials to make them conduct electricity? This is because it enables electronic devices to process information using the binary numbers 0 and 1. For instance, high voltage means 1, whereas low voltage means 0. By controlling the flow of current in this way, we can manage the digital signals and therefore control the electronic devices. Then what is a semiconductor made of? The most commonly used material is an element called silicon, the second most abundant element on Earth after oxygen. It is easily found in sand, soil, and rocks. The first semiconductor device was a transistor created in 1947 by Bell Labs in the US. A transistor is a component that can amplify or switch electrical signals, similar to a tap controlling water flow. Through transistors, we can control the flow of electrical current, which helps distinguish the binary signals of zeros and ones. A semiconductor chip, or more precisely, an integrated circuit, is an assembly of countless transistors that can store data and perform tasks, much like our brains. In a simple analogy, the chip resembles a city, with the areas where the transistors sit being doped areas where electrical current is allowed. Thanks to the structure of a transistor, it can act like a traffic light, allowing the current to flow when it shows green and stopping it when it shows red. Apart from transistors, other components like diodes, resistors, and capacitors are also integrated into the same single chip to enable its functions. The first semiconductor chip was eventually developed in 1958. Next, let's explore how semiconductor chips are made. In a very general and simplified way of explaining things, sand containing silicons is first heated until it melts into a high purity liquid and then solidifies into a silicon rod. The rod is sliced into discs called wafers. The bigger the wafer, the more chips it can produce. The wafer is then carefully cleaned, polished, and doped with specific impurities to achieve the desired electrical properties. Tiny circuit patterns are created on the wafer using a process called photolithography, followed by the removal of any unwanted materials. Some of these steps get repeated numerous times before the wafer goes through thorough testing, gets chopped into individual chips, and finally gets packaged up and ready to use in electronic devices. Since the inception of ChatGPT, pretty much everyone is talking about AI, which means that more and more cutting-edge semiconductor chips will be required in devices applying AI to accommodate the complicated computations required in AI applications. For instance, AI computers, AI cars, AI smartphones, AI medical devices, and many others. The entire semiconductor supply chain has also transitioned from the beginning where one company handled everything to a niche and dedicated ecosystem. TSMC was founded in the 1980s as a company exclusively for the manufacturing of semiconductor chips, as it saw the potential for a specialized foundry dedicated solely to the semiconductor chip production. It does not involve in chip designing at all, nor does it heavily participate in the testing or packaging stages of the supply chain. As time passed, this proved to be a very correct and far-sighted decision, as TSMC now generates 90% of the advanced semiconductor chips worldwide and over 60% of the entire semiconductor chip market. Moreover, hardly any company can match its manufacturing power, as establishing such a factory is extremely expensive, labor-intensive, and requires very specific industry knowledge and expertise. Speaking of the present, the TSMC factory is literally the most expensive factory on the planet.
Finding the funds to build a new chip plant is itself an extraordinary challenge.
In the past week, the CEO and the co-founder of Nvidia, Jensen Huang, chose to visit Taiwan again to highlight the technological power this island possesses.
I am very happy to be back. I'm very happy to be here in Taiwan. Taiwan is the home of our treasured partners.
Nvidia has arguably become a celebrity in the tech world and among investors, as its value has exponentially grown in the last few years. Why would Nvidia value Taiwan, or specifically TSMC, this much? Because nearly every electronic device we use today depends on semiconductor chips. For a company like Nvidia that generates most of its revenues from selling GPUs for video games, computers, AI applications, it requires particularly high quality or advanced semiconductor chips as part of its production components.
It would be very difficult for Michael and I to do our jobs. It would be very difficult for us to serve Bill and his company. And so the technology industry depends very heavily on Taiwan and continues to for some time.
So the relationship between Nvidia and TSMC is akin to that of an architect and a contracting builder. Nvidia in this case provides the chip design and TSMC makes into a physical chip based upon the design. The importance of Taiwan to the technology industry is further emphasized by a parallel visit made by the CEO of AMD. This created an interesting situation where the CEOs of two of the world's most compelling technology companies specializing in GPU production are on the same island, without directly competing with each other.
We're looking at all options.
Obviously, the semiconductor supply chain is a lot more complicated than this. Similarly to building a house, after a blueprint of a building is made, an interior designer might take over to add layers or components before it is passed on to contractor builder. After a chip is made, we also require packaging and testing to ensure the quality is met before it is eventually applied to electronic devices for use. Not to mention companies that provide equipment and materials at different stages of the supply chain. All of this requires different specialities and labors to achieve. While some companies do it all, just like what we have seen in the past, with a higher technology required to meet our future needs, we see a more and more dedicated allocation of work in this supply chain. Despite the unprecedented need for semiconductor chips in today's world, numerous challenges have arisen. Take TSMC, the global major semiconductor chip manufacturer, as an example. The increasing political tension between Taiwan, China, and the US raises questions about the company's production power in the future, something that is not entirely within the company's control.
China has been clear about its intention to eventually take control of Taiwan, which could have devastating consequences for the current AI revolution.
Secondly, it's a common trend that the number of transistors on the semiconductor chips doubles every 2 years. This means semiconductor components keep getting smaller and smaller to fit more of them on the chip, which gets closer to their physical limits. To address this, TSMC has turned to 3D packaging technology to increase the density of components without having to physically downsize them further to improve chip performance. As a global strategic move and a way to mitigate potential political impacts, TSMC has been keen on expanding overseas presence in the US, Japan, and now even in Germany.
TSMC is investing $40 billion here in Arizona, the largest foreign investment in the history of this state.
However, TSMC's management style, which has long been practiced among the Taiwanese workers, has faced significant backlash, especially in the society where the cultural differences are considered significant. These are the main challenges TSMC faces to maintain its strong position in the technology world. So very exciting times ahead for technology folks and even non-tech folks like myself, because I'm very eager to benefit from any cool new technology. While the entire world discusses AI and its potential to replace most jobs in the future, I still believe that a human touch will still be required and essential, because certain human qualities are just so difficult to be replicated by machines, if not impossible. When one door closes, another opens. Skills may be replaced, but new skills will emerge as well. Let us embrace all possibilities with an open yet cautious mind, and remember that the key to survival isn't whether our ability can be leveled with a machine, but our ability to coexist with it.